Okay, so in chapter 4, we'll be talking about discrete random variable. Okay, and in the first section we have is types of random variable. So before we go to the type of random variable, let's define the random variable. Okay, so random variable is a variable. Okay, is a variable that assumes numerical values associated with the random outcomes of an experiment. Okay, where one and only one numerical value is assigned to each sample point. Now it's a variable. Okay, so it's a variable that takes a numerical values. Okay, that takes a number, or we assign a number to that variable. Okay, and the number for that variable is one and only one. So let's take an experiment of like tossing a coin. Okay, so we have an experiment of tossing a coin. So when we toss, okay, let's two coin. What are the possible outcomes we get when we toss two coin? So the possible outcome is our sample space. So our experiment is tossing a two coin, and when we toss a two coin, we have a sample space, and our sample space has a sample points. So the sample points are, we might get head, okay, we might get head tail, we might get tail head, or we might get tail. Okay, so this is an experiment tossing a two coin, and these are the basic outcome of this experiment. Okay, these are the sample point. Now let's call our x is, okay, so x is the number of heads observed. So we call our x to be number of heads observed. So we define our x. X is a variable. Okay, this is a variable, and x is the number of heads observed. Now for each sample point, okay, so for each sample point, can we assign a number here? So what will be an x value for our sample point HH? So what will be x here? 2, right? Because we have 2 heads. So our first sample point HH takes a value 2. In the similar way, what will be the value of x for our sample point HT? 1. What will be the x value for our TH? 1. And what about the x value for this sample point TT? 0. Okay, so here we have an x variable. Okay, and this x takes a number, numerical values like a 0, 1, 2. Okay, and this kind of variable, okay, so this kind of variable x is our random variable. Okay, we assign a number, we give a numerical value for that variable. Okay, so this is our random variable. So x, the number of heads observed, is the random variable here. Okay, now here we have an more examples here. Okay, suppose the Environmental Protection Agency, EPA, takes readings once a month on the amount of pesticides in the discharged water of a chemical company. If the amount of pesticide exceeds the maximum level set by the EPA, the company is forced to take corrective action and may be subject to penalty. Consider the random variable x. Okay, so we have x, random variable, to be the number of months before the company's discharge exceeds the EPA's maximum level. So here we define our x to be the number of months. Okay, so x is a variable here, and that x is the number of months. Now can you think of a number that this x takes here? So what kind of number this x variable takes here? Is it going to be up to 12, or we can have like 15 number of months? So our x is number of months, right? So we can have a 1 month, 2 month, 3 month, 4 month, like 15, 16, 20th month, 20 months, right? So x takes a number. So what are the possible numerical values our x takes? So x takes a number 1, right? Or can we have a zero? Zero. So what does it mean by 0 month? So what does, like if we are, okay, does it tell the 0 month or can we just denote our first day as a 0 month? So today is our 0 month, and like after 30 days we call it 1 month. Okay. Now is it possible that our x takes a value 0 here? Now, if you want to define, or you can, okay, but like in general, we have one month, 2 month, 3, right, 4 month. So how far we can go? So we can have like infinite number of months, right? So here, so this x is a random variable, okay? X is taking a numerical value. So the next example here, our second random variable of our interest is so we have x, and this x is the amount of x pesticide, okay? So we have another random variable x, and that x represents the amount of pesticide in milligrams per liter found in the monthly sample of discharged water from the same chemical company. What values can this random variable assume? Now, for the first example, we had x as a number of months, and our x takes a number like a 1, 2, 3, 4, 5, 6, 7. Now, in example 2, we have x as an amount of pesticide. Now, what are the number that we assign for the amount of pesticide? So it can take any number greater than 0, right? So it can take 0.001. Is it possible for us to make a list of every those possible numerical values for this x? Can you make a list of all those number that x takes here? So x is the amount of pesticide, and we are assigning a number for that amount of pesticide. Now, can we make a list of every number, every numerical values for these x values? We can't, right? But what do we know? Our x takes any number. Okay, so x is, so let's write down for now. X can be any number greater than or equals to 0, right? So how many numbers do we have? We have like infinite number, right? Is it possible for us to make a list? Can we make a list of every number greater than or equals to 0?
Wouldn't it?
Yes.
Why would it be equal to? Oh, I guess because you can have
So
zero.
yeah, we can have a 0 amount, right? So if it's nothing, then it's gonna be 0. So here we don't have now. So now, what's the difference between the number that our x takes in example 1 and 2? What is the difference here? So in number 1, our x is 1, 2, 3, 4, 5, right? We can make a list. I know it goes all the way like up to infinite, but we can make a list. Now for number 2, our x is any number greater than or equals to 0. Now can we make a list here? Can we make a list of number greater than or equals to 0? So if you want to make a list, where do you start from? 0. So what will be the next number after 0? 0.00. How many zeros you want to add? So it's not possible for us to make a list, right? Okay. Now on the base of, on the type of the numerical values that we assign for our random variable is of two type. Okay. One type of random variable is discrete random variable, and the second type of variable is continuous random variable. Okay. Now, if we have a random variable that assume a countable number of values, okay. So if we have a random variable and that takes a countable number of values, then we call it discrete. Now, how do we know it's countable or not? Now, out of these two examples, so we have our x 1, 2, 3, 4, okay, and we have x greater than or equals to 0. So which one is countable? The first one, right? So if we can make a list of the values of x, that is countable, okay? And if your any random variable takes a countable number, then those random variable is a discrete random variable. Okay, so the random variable that takes a countable number, it means it's a number that you can make a list, like the example 1. Okay, so here, just let me write down the definition for countable number. So it's a number that you can list. Okay, so if you can write down the number, okay, okay, this is a countable number, and if we have any random variable that takes a countable number or that takes a number we can list, are the discrete random variable. Okay, now the next type is continuous, and this continuous random variable, it assumes a number. Okay, it takes any number, okay, between some interval, okay, like the one we had in our second example. So here our x is greater than equals to 0. Our x can be any number, we can't make a list. Okay, so this x, the x in the example second, the amount of pesticide is our continuous random variable, but the number of months is our discrete random variables. Okay, so here we have more examples. So the number of seizures an epileptic patient has in a given week. So what are the possible x values that we can have for this random variable? So how do we assign a number here? So the number of seizures an epileptic patient has in a given week. So it can be 0, right? 1, 2, 3, or like 4. Okay, we can make a list of the values of x here. Okay, so this is our discrete random variable. So the number of voters in a sample of 500 who favor impeachment of the president. Now, what are the possible x values here? What kind of x values this variable takes? Yeah, it's 0 to 500, right? So 0, we can make a list, right? So 0, 1, 2, 3, 4, okay? So this is also our discrete random variable. The change received for paying a bill. Now, can you make a list of a change that you receive after paying a bill? We can make a list, right? So you might get, okay, let's say like 25 cents, right? 75 cents, or like $2. Okay, so if you can make a list of numerical values for that random variable, it is discrete random variable. The number of customers waiting to be served in a restaurant at a particular time. Okay, it takes a number like a 0, 1, 2, 3, right? The shoe size of a tennis player. Can we make a list of a shoe size of a tennis player? We can make a list, right? So it can be 7, 7.5, 8, 10, right? So this is our discrete random variable. So if you can make a list of the numerical values for that random variable, it is a discrete random variable. The next type is continuous random variable, and this continuous variable, it takes any number, okay, between some two number. So the length of time between arrivals at a hospital clinic. So length of time in seconds between arrivals at a hospital clinic. Now, what are the possible values that we can assign for this variable x? Can you make a list of the length of time? So it can be any, right? It can be like a 10 second, or we do have, if you want to count, okay, now it does tell us in seconds. So we can have like a 1 second, 2, 3, like, so it's gonna be like it takes any number, okay? So in the similar way, the length of time it takes a student to complete 1 hour exam. Now, so in general, you get like 60 minutes. Now, can we make a list of every possible length of time that these students take to complete exam? can you, is it always gonna be like a 5 minute, 10 minute, or 15 minutes? So is that possible to make a list here? Okay, so this is our continuous random variable. The amount of carbonated beverage loaded into a 12-ounce can in a can filling operation. Okay, the amount. So it takes any number. Okay, this is continuous. The depth at which a successful well drilling venture first strikes a well. So it can take any number. Okay, we can't make a list. So this is our continuous random variable. The weight of a food item bought in a supermarket. So it takes any number, right? So we can't make a list. And this is our continuous random variable. Okay, so if you can make a list of the values for that random variable, it is a discrete. And if you can't make a list, then we call it a continuous random variable. Okay, so what would be the number of bacteria in a particular cubic centimeter of our drinking water? Is it a discrete or a continuous? The number of bacteria in a particular cubic centimeter of our drinking water. Is it discrete or a continuous? The number of bacteria. Now can you make a list of the number? You can count it, right? So you can have a 1 bacteria, 2 bacteria. No, it's like a never-ending list. You may gonna have like a never-ending list, but you can list like a 1, 2, 3, 4, right? Okay. So if you can make a list, then it's always discrete random variable. Okay. Whatever the amount of water flowing through the Hoover Dam in a day, it's going to be a continuous. Okay. The number of violent crimes committed per month in your community. The number discrete, right? Okay. Okay, so this is all for our section 4.1. Okay, 2 types, discrete and continuous random variable. Okay, now the next here we have the probability distribution for a discrete random variable. So we will focus ourselves in a discrete random variable. Okay, so discrete means we will be able to make a list of a number that our x variable takes. Okay, and for this discrete random variable we will create a probability distribution. Okay, now before that let's do this example here. So we have the experiment of tossing 2 coins. Our x is the number of heads observed. Now what is this x? Is it a continuous or a discrete random variable? Discrete, right? So if we go back here, so we started with this example and our x takes on values 0, 1, 2. Okay, so this x, number of heads observed, is a discrete random variable. So we have a x as a discrete random variable. Okay, find the probability associated with each value of a random variable x, assuming that the 2 coins are fair. Okay, now so our sample space is head, head. When we toss 2 coins, we get head, tail, tail, head, tail, tail. Okay, our x is the number of heads observed. Now what are the values of x? It can be 0, 1, 2, right? So these are the values for x. Now let's find a probability. Okay, now we want to find the probability that x takes each of these values. Okay, so does anyone have any question? How did we write 0, 1, 2 here? So our x is defined as a number of hits. Okay, so for each sample point we assign a number. So head, head is 2, right? Head, tail is 1, tail, head is 1, tail, tail is 0. Okay, now let's find the probability that our x takes a value 0. So let's find a probability that x takes a value 0. Now what does it mean for us? So what does it mean? So what probability are we finding here? So what does it mean for us? So we are finding the probability of observing telltale, right? So 0, so x, the value of x 0 means, so our sample point is telltale, okay? So this is same as probability of observing telltale, okay? And what is this probability equals to? 1/4, right? Now similarly, let's find probability that our x takes a value 2. And what does it mean for us? What are we finding here? We are finding the probability of observing head, right? So this is same as finding probability of observing head. And what is this probability? 1/4. Okay, we have one head and total sample point is 4. So 1 divided by 4. Now, so we have, let's find probability that x takes a value 1. And what does this mean for us? So if we are finding the probability that x takes a value 1, what does this mean for us in this example? So what are we finding here? So we are finding probability of observing head, tail, or tail, head, right? So this is same as finding probability that we observe head, tail, or tail, head. Do you have any question here? And the reason here is both of these sample points takes a value 1, right? So we find a probability that we observe head, tail, or tail, head, okay? And this, so this is here, so this is OR, right? OR is union. So this is same as probability of observing head, tail plus probability of observing tail, head. What is the probability of observing head, tail? 1/4. And the probability of observing tail, head is also 1/4. And this is 1/2. So the probability that x takes a value 1 is 1/2. Okay. Now any question up to here? Okay. Now let's construct a table here. Okay. So we have a table here. Our table consists of the values of x. Okay. The number x takes. Okay. So for this example, what are the values of possible values of x? X takes 0, right? X takes a value 1 and x takes a value 2. Okay, so we have a table here with the values of x and the corresponding probability. Okay, so P of x is the probability that x takes this number. Okay. Now, what is the probability that x takes a value 0? What we had? So, what is the probability that x takes a value 0? 1/4, right? So, we have 1/4. What is the probability that x takes a value 1? 1/2. And what is the probability that x takes a value 2? 1/4. So, here we have a table. And this table consists of possible values that we assign for our random variable and the probability that x takes those values. Okay, and this table, okay, we call this table as a probability distribution. Okay, so this table is probability distribution. Okay, so this table is probability distribution. So this table or this distribution always has the values x takes, and it also has the probability that x takes those values. Okay, so our probability distribution is a table. Okay, so probability distribution for a discrete random variable can be a graph, can be a table, or a formula that specifies the probability associated with each possible values that the random variable can assume. So any table, okay, any table, graph, or a formula that has the values of x that we assign and the probability of x taking those values. We call those table, graph, or a formula as a probability distribution. Okay, so the probability distribution has a two thing. Okay, so we have the requirement for the probability distribution. Okay, the first requirement that the probability distribution is, so the first requirement is, so we have p of x, and p of x is, this is the probability that x takes values like a 0, 1, 2. Okay, this p of x has to be always greater than equals to 0. Okay, the probability that x takes the number has to be always greater than equals to 0. So this table, we had 1/4 here, 1/2 here, 1/4 here. All of these values are greater than 0, right? Okay, so this is the first requirement. And the second requirement is the sum of, so this is the summation, the sum of probability of x, it has to be always equals to 1. So when you add the probability of observing the values of x in a given distribution, the sum has to be always equals to 1. Like in this table, if you add every probability, isn't the sum equals to 1 here? 1/4 plus 1/2 plus 1/4, it is 1, right? So whenever you see a probability distribution, these are the two requirements. Each probability p of x has to be greater than equals to 0. Okay, and the sum of the probability has to be equals to 1. Okay, so these are the two requirements for any probability distribution. Now for the same, okay, now let me take a question if you have any. Does anyone have any question? So what does it, so whenever you have a probability distribution, so what will be your expectation? What do you see? No, just like for example, you are given with probability distribution. Okay, so I'm gonna give you probability distribution. So what you will expect? You will expect table or a graph, or it can be a formula. Okay, so it's always table, it's always graph, or it can be formula. And there is two things in that probability distribution: the values of x, the possible values that we assign to x. Okay, and the next we have is the probability that x takes those values. Now for the same probability distribution, we can draw a graph here. So okay, so let's draw a graph. So we have our x in the horizontal axis. So we have x in the horizontal axis and p of x as the vertical axis. So this is our p of x. Okay, now what scale do we have on the horizontal axis? So what are the values that x takes? X takes 0, 1, 2, right? So we have 0 here, 1 here, 2 here. So on the horizontal axis, you write every numerical values that x takes. So let's say this is 1/4, this is 1/2. Because we have like the 1/4 is the smallest one, and the biggest value is 1/2. Now for each x value, you can use a bar or a straight line to represent p of x. So for when x is 0, what is p of x? It is 1/4, right? So you can draw a bar, okay, or you can use a vertical line of a height 1/4, okay. So when x takes a value 1, the probability is 1/2. So you draw a bar of a height 1/2. When x takes a value 2, the probability is 1/4. So you draw a bar of a height 1/4. Now instead of bar, you can use a vertical line. Okay, so this is x, this is p of x. Let's say this is 1/4, this is 1/2, 0, 1, 2. So we can use a vertical line. Okay, so we have vertical line of a height 1/4 when x is 0. When x takes a value 1, the probability is 1/2. So you draw a vertical line of a height 1. Okay. So you draw at 1. Okay, so height 1/2 and 1/4. Okay, so this is also probability distribution. So the horizontal axis gives the possible x values. Okay, the vertical axis give us the probability. Okay, so if you have a graph, table, or a formula, we call it a probability distribution. Okay, now let's do example here, more examples. So for example, we have this table. Okay, so -4, 0, 1, 3. We have p of x 0.1, 0.2, 0.4, 0.3. Now the very first question, what is this? What do we call this table? We call this table probability distribution. Okay, so this is our probability distribution. Now for this probability distribution, okay, now let's list all values, list the values that x may assume, list the values, okay, may assume. Okay, now from this probability distribution, can you make a list of a values that x assume here? Can you assign any number? So what are the values that x takes here? Okay, x takes a -4, 0, 1, 3. Okay, you are answering based on this probability distribution. For number, okay, next. So what value of x is most probable? What value of x is most probable? What does it mean? So yes, so which x value has the highest probability? When x is equals to 1, right? So when x is equals to 1, the probability is 0.4. Okay, what is the probability that x is greater than 0? So we are asked to find the probability that x is greater than 0. Now we can just rewrite this as a probability that our x is greater than, does it tell equals to? No, right? So probability that x is greater than 0. So this is what we are asked. Now how many x values do we have which is greater than 0? So we have 1, we have 3, right? So we are asked to find the probability that x is greater than 0 is same as we are asked to find the probability that x is equals to 1 and the probability that x is equals to 3. Do you agree here? So we are asked to find the probability that x takes a value greater than 0. Again, we have 1 and 3, the x values which is greater than 0. And you add the probability of getting each of these numbers and we get that probability. So this is 0.4 plus 0.3 which is equals to 0.7. So 0.7 is the probability that x is greater than 0. Okay, who can tell me the probability that x is equals to -2 from this distribution? What is the probability that x is equals to -2? Do you all agree? Why it is 0? it doesn't take the negative 2, right? So this we don't, so our x takes only 4 number, negative 4, 0, 1, and 3. And if you are asked to find the probability that x takes any other number other than this, then it's always 0. Okay, so the probability, so here, so the probability that x takes a number negative 2 is 0. Okay. Okay, any question on this example? Okay, let's do one more example. Okay, so we have table probability distribution. Okay, and what kind of x is this? Is our x random, discrete random variable or continuous random variable? So for this x, is it discrete or a continuous? Discrete, right? We can make a list. See, we have a negative 4, 0, 1, 3. Okay, so you are making a list of values of x. So this is discrete random variable. Okay, so next here we have this probability distribution, p of x. So we have negative 2, 0 0.1, negative 1, 0 0.15, then we have 0, 1, 2. So 0 0.4, 0 0.3, 0 0.05. Okay, before we start, okay, let me start from Sam, right? Okay, Daniel. Oh, sorry, Dathan. Let me start with Dathan, right? Okay, so what does this number for you? Okay, now from this table, what is this 0.3 for you?
Probability that x will be 1.
That's right. So that is the probability that x takes a value 1, right? Okay, Daniel, what about this? What is this number? 0.05. One more time. Probability that x, you are close. Not okay. So this is probability that x takes a number 2. Okay, if you are asked what is the probability that x takes a value 2, then it is 0.05. Okay, so Emily, what does 0.4 for you? The probability that x equals to 0, or the probability that x takes a value 0. Okay, Faith, what is 0.15 for you? One more time.
It's the probability that x takes a value of negative 1.
Okay. Mariana, right? So what is the probability that x takes a value negative 2?
0.1.
Okay, that's good. All right, now, so this, you should be able to just able to read the table. Okay, now we have this table. Now let's do some examples here. Now let's find, so number A, so we have p of x less than equals to 0. So what does this mean for us, Zayden? So what are we asked to find here in number A?
The x is greater than or less than or equal to 0, so everything is 0.
Okay, but what is the key word here? So what we are finding? Finding?
The x's. What you're listening.
Are we finding the values of x?
Yeah.
No. So what does this p tells us?
Probability.
Right, so we are finding the probability, right? Probability that x takes a value less than equals to 0. Okay, now for this table, for this x, what are the so what numbers do we count here? So we have negative 2 less than 0, we have negative 1 less than 0, and we have 0 equals to 0, right? So this is same as finding probability that x takes a value negative 2, okay, plus probability that x takes a value negative 1 plus probability that x takes a value 0. Now Do you have any question here in the very first step? Okay, now once we have this, everything is given. So probability that x takes a value -2 is 0.1. The probability that x takes a value -1 is 0.15 plus 0.4, and this is okay 10, 25, 0.29. Okay. Now I want you to find probability that x is greater than -1. Now can you find, okay, so let me make a, so I want you to find number B. So number C is find probability that x takes a value greater than equals to -1, less than equals to 1. And I want to see your work, okay? Don't give me a final answer. I want to see every detail work.
Would A be 0.65?
For B,
A.
oh, is it 0.65?
Yeah.
Oh, thank you. Oh, this is 40, right? Okay, thank you. So 0.65. So for number D, I want you to find P that x less than equals to 2. Number E, probability that x is greater than -1, less than 2. And finally, number F, probability that x is less than 1. I want you to show the detailed work. Okay, find these probabilities.